do these two, 5x. This is elimination, substitution. Okay. So remember, for substitution, you have to rewrite one of them. Take the easy one out, right? And write in terms of, let's say, the first one, right? So here's my system. I'm going to rewrite this. So I'm going to isolate y. So if I isolate y, let me do it here at the bottom. I get 5x plus y equals 9. I'm going to do minus 5x on both sides. And I get y equals negative 5x plus 9. Get used to writing in this format, especially when we're graphing, because that's going to be our slope, and this is going to be our y-intercept. So now that I have what y is, I can go, so let me write this over here. So that's going to, I'm going to use this version of it. Now I'm going to, let me write 1 and 2. In equation 2, I'm going to replace y with negative 5x plus 9. And I'm going to put that in parentheses. 10x minus 7 times negative 5x plus 9 equals negative 18. Let's solve this. 10x plus 35x minus 63 equals negative 18. Combine like terms. These two gives me 45x. Minus 63 equals negative 18. I'm going to do plus 63 on both sides. That goes away. I'm going to get 45x equals 13. 45. Divide both sides by 45. X equals 1. Now that I found x, I can use this equation here, right? Find y. So y equals negative 5x plus 9. But we just found that x equals 1. So y equals negative 5 times 1 plus 9, and y equals 4. So my solution is 1 comma 4. This is the point that satisfies equation 1 and equation 2. So I'll quickly do the check. So I'm going to erase this. So for my check, take the original equations. Let me check equation 1. So I'm going to have 5 times 1 plus 4 equals 9. And you can clearly tell that it works for equation 1. In equation 2, this is 1. I'll replace this x and this y with 1 and 4. So I get 10 times 1 minus 7 times 4 equals negative 18. 10 times 1 is 10, minus 28 equals negative 18, and it works for both. All right, so check and check. So the solution to our problem is 1, 4. So is the point of intersection between two lines. Equation 2, negative 3x plus 7y equals negative 16. The second one is negative 9x plus 5y equals 16. So I want to do substitution. Let's see whichever one is easier. I don't want to deal with fractions. Hang on a second. That's going to be divided by 5, so that doesn't help. What if I... Yeah, it doesn't matter which one I use. They both gives me fractions. So I'm just going to keep this, rewrite. So this is equation 1, this is equation 2. I'll take equation 1. And I'm going to isolate, it really doesn't matter. All right, so let's just do isolate y. So we do plus 3x, plus 3x. It's not going to make a difference. That goes away. I'm left with 7y equals 3x minus 16. Divide this by 7, which means I divide both sides by 7. So I get y equals 3 over 7x minus 16 over 7. All right, so that's what this becomes. Y equals 3 over 7x minus 16 over 7. Now I'm going to replace that. I'll take equation 2. All right, here's my substitution part. Equation 2 is negative 9x plus 5 times, and I'm going to replace the y here is what we just found. It's 3 over 7x minus 16 over 7, and that should give you 16. Let's do the distributive property. So negative 9x plus 15 over 7x minus, leave it over 7. 5 times 16 is 80 equals 16. You could combine like terms right now, but before I do that, I'm going to multiply everything by 7. So I'm going to take this and I'll put times 7 here because I want to get rid of the denominators. So 7 times, so we're going to multiply everything on the left and the right side of the equal sign by 7. So 7 times negative 9 is negative 63 x. And then 7 times 15 over 7 is just going to be 15 x. Minus, and then 7 times 80 over 7 is just going to be 80. And 16 times 7 is 112. So that's, see, makes my life a little bit easier because I don't have to deal with fraction. Combine like terms. Let me change colors. I'm combining these two guys here. So negative 63 and 15 now give me 48x, negative 48x minus 80 equals 112. I'm going to add 80 on both sides, and I get negative 48x equals 192. And hopefully 192 divided by 48 equals 4. Oh, this works out nicely. So I'm going to divide by negative 48 and divide this by negative 48. So x is going to be negative 4. Okay, so notice that everything we've worked on so far comes into play right now, right? So x equals negative 4. I'm going to take the second equation. So negative 9, and wherever I see the x, I'm going to replace it with negative 4. So negative 9 times negative 4 plus 5y equals 16. These two becomes 36 plus 5y equals 16. Subtract 36 from this side, subtract 36 from that side. That goes away. I'm left with 5y equals negative 20. Divide by 5, divide by 5, y equals negative 4. So the answer to this problem is the point, or the point of intersection of these two lines is negative 4, negative 4. It's the only point that satisfies equation 1 and equation 2. So now I'm left with a check. So I'm going to erase everything here. Right? So we don't need that. Well, you can always use the rewind button. Let's say equation 1, negative 3 times negative 4 plus 7 times negative 4, and that hopefully equals negative 16. Negative 3 and negative 4 is 12. 7 and negative 4 is negative 28 equals negative 16, and that indeed works. So equation 1, check. Equation 2, negative 9 times negative 4 plus 5 times negative 4, and that somehow should give me 16. These two combined gives me 36. 5 and negative 4 is 20, negative 20. Does that equal 16? Sorry. Negative 16, positive 16. It does. So I know I'm good. So this point, negative 4 and negative 4 works for equation 1 and equation 2. All right, so as you can tell, so we said 9, 11, and 2, right? So I'm going to take this guy here, copy. All right, so this one is a little bit easier because y is already isolated. We don't have to do much. So make that a little bigger. One less step we have to do, right? So we already have the second equation. It's already says y. It's already in terms of x. So y equals x minus 1. So I can go. Let me write equation 1 and equation 2. Alexa, stop. So I'm going to go to equation 1, and it's 2x minus 3 times, and then wherever I see the y, I'm going to replace it with x minus 1. And that equals negative 1. 2x minus 3x plus 3 equals negative 1. This is negative x plus 3 equals negative 1. Minus 3, minus 3. So I get negative x equals negative 4. You can divide both sides by negative 1. Or multiply both sides by negative 1. Whatever you want to do. And x equals 4. So I know what x is. Now I'm going to find what y is. So I'm going to take this equation. So equation 2. Y equals, and instead of x, I'm going to write 4. 4 minus 1, and y equals 3. So the point of intersection of these two lines is the point 4 and 3. And that satisfies, hopefully, both equations. So let's check. Let me just rewrite this over here. Let me erase this. I'll do my check. Check. Equation 1. 2 times 4 minus 3 times 1 should give me negative 1. Sorry, that's a 3 here. 2 times 4 is 8. 3 times 3 is 9. And if you Do 8 minus 9, you get negative 1, which equals negative 1 on the other side. So equation 1 worked out. Equation 2, y equals x minus 1. The y is 3, x is 4, and you see that it satisfies equation 2 as well. So the 0.4 and 3 is correct. So that's literally substitution, right? It's just a lot of work, but nothing too bad. Now let's go to elimination. We're going to do the same 3 problems, 7, 9, and 2. Let's do 7. 7 says negative 6x plus 6y equals 6. Negative 6x plus 3y equals negative 12. Now, notice that in this particular problem, I already have my x variable with the same coefficient. So I don't have to change equation 1 or equation 2. I don't have to multiply the top by something or the bottom by something else to have same coefficients. So I can go straight to elimination. Now, what I'm going to do, I'm not going to add, but I'm going to subtract line 1 minus y2, equation 1 minus equation 2. So I get negative 6x minus negative 6x. That's just 0. So I don't have to worry about the first column. The second column, I get 6y minus 3y. I get 3y. 6 minus negative 12 is the same thing as 6 plus 12, so that gives me 18. And then divide by 3, divided by 3, y equals 6. So I have one of them. Now, you can either pick equation 1, equation 2, pick the easier of them. Doesn't matter. It really doesn't matter. So I'm going to pick equation 1, so I get negative 6x plus 6 times 6, because I'm replacing the y with the value we just found, which is 6, equals 6. Negative 6x, 6 times 6 is 36, equals 6. Minus 36 on both sides, and I get negative 6x equals negative 30. Divide both sides by negative 6, and x equals 5. So our point, or our solution to this problem is a 0.56, which satisfies both equations. So let's do our check. So I'm going to do equation 1, which is this one. Negative 6 times 5 plus 6 times 6 equals 6. So remember, I'm replacing this guy, which is the x value, and this guy, which is the y value here. Okay, I replace the x with 5 and the y with 6. So now, negative 6 times 5 is negative 36. Sorry, negative 30. And 6 times 6 is positive 36, which equals 6. And negative 30 plus 36 is indeed 6. So equation 1 worked out nicely. Equation 2, negative 6 times 5 plus 3 times 6 equals negative 12. Let's see. Negative 6 and 5 is negative 30. 3 times 6 is 18. Does that equal negative 12? Yes, it does. So the left side equals the right side. So again, the 0.56 exists on both lines. 9. 5x plus y equals 9. 10x minus 7y equals negative 18. Now, they don't have, if you look at the variables, the coefficients of x, one is 5, the other is 10. You can multiply the top by 5, right? I can multiply this equation here by 5, so I can have the coefficient, both share coefficient of 10 and 10. If you look at the y, 1 is negative 7, and here the coefficient is 1, so I can multiply the top one by 1. It's your choice. So, I'm going to make it simple. Put this in parentheses. I'm going to multiply that whole equation, everybody, times 5. That's going to change to, sorry, not times 5, times 2. Oops. Times 2. So the first equation is going to change to 2 times 5x is 10x. 2 times y is going to be 2y. And then 2 times 9 is going to be 18. Right? So that's the equation I'm going to use. And the bottom one stays the same. So it's 10x minus 7y equals negative 18. So now the hardest part here is decide where you're going to add equation 1 to equation 2 or subtract. Remember, the purpose of that is to get rid of one of the variables. Now, let's say I add it here. I'm just going to do it. 10x plus 10x is 20x. 2y plus negative 7y is negative 5y. And notice that by adding, I didn't get rid of the x nor the y. So adding is not the way to go. So let's subtract. If I subtract, I get 10x minus 10x, and that becomes 0. So they're gone. 2y minus negative 7y is the same thing as 2y plus 9y. Sorry, minus 2y plus 7y, which gives me 9y. 18 minus negative 18 is going to be 18 plus 18, which is 36. Divide both sides by 9, and y equals 4. Good. I found my y. Now I need to find the x. So I have two equations here. The original. Go back to the original. So this is equation 1, and I'll put it over here, and this is equation 2. So I pick one of them. Doesn't matter. I'm going to pick equation 1. 5x plus y equals 9. 5x plus 4 equals 9. Right? Now we replace the y with this value over here. We're going to do minus 4 on both sides. That goes away. I'm left with 5x equals 5, and divide both sides by 5x equals 1. So the solution to my system here is the point 1, 4. Let's do the check. So in both equations, replace x and y with our values of 1 and 4. So we get equation 1, 5 times 1 plus 4 equals 9. Is that true? Yes, it is. So equation 1 is a check. Equation 2, 10x, or 10 times 1, because x equals 1, minus 7 times y, which is 4, should give you negative 18. Well, 10 times 1 is 10. Negative 7 and 4 is negative 28. And this works out as well. So we're good for that problem. So the solution, 1, 4, satisfies both equations. Clear. And then the next one that I asked you to do, right, using elimination, is this one. So I'm going to copy. All right, so for this one, again, this one came already very easy. If you look at the coefficients of x, they're both 4s. If you can look at the coefficients of y, one is 8, one is 2. So you don't have to eliminate the x's because they're 4s. If you want to multiply the bottom one by 4 so that the y's can be eliminated, be my guest to get more practice. But I'm not going to do that. So now the hardest thing, like I said in the previous question, is deciding whether you're going to add equation 1 as equation 2 or subtract. And in this case, we're going to add. We've got a plus sign over here. 4x plus negative 4x is 0x, so that's gone. 8y plus 2y is 10y. And then 20 plus negative 30 is negative 10. Divide both sides by 10, y equals negative 1. Now we're going to pick one of the equations, the top one, equation 1 or equation 2, and replace the y value right here with negative 1. I'm just going to stick to the first one. So 4x plus 8 times negative 1 equals 20. 4x minus 8 equals 20. I'm going to add 8 to both sides. 4x equals 28. Divide both sides by 4. X equals 7. So apparently our solution is the point negative 1, 7. You got to do a check. So let's go to both equations. The first one, equation 1, we got 4 times negative 1 because I'm replacing this x value with negative 1 and I'm replacing this y value with 7. So 4 times negative 1 plus 8 times 7 equals 20. Uh-oh, doesn't look correct. Where did I mess up? 10y, 20, negative 10, that equals negative 1, negative 8. This doesn't look correct because 4 times negative 1 is negative 4 plus 8 times, that doesn't, okay, I did something wrong. Well, because if I do the substitution, negative 4, and this is 56 equals 20, we can tell right off the bat that's not going to work. So I messed up somewhere. Hang on a second, we're adding 4 plus negative 4. That goes away. 8 plus 2y is 10y. 20 plus negative 30 is negative 10. Divide both sides by 10, y equals negative 1. So that seems okay. Take the second equation. Replace y with negative 1. 4x minus 8 equals 20. Plus 8 plus 8. 20 plus 8 is 28. Divide both sides by 4. X equals 7. Oh, x equals 7. Sorry. Oh, there was my mistake. I wrote the point incorrectly. So it's not 1 and negative 7. It's 7, negative 1. So remember, it's x comma y. So that was my mistake. All right, let's do our check. So again, we're replacing the x with 7 and the y with negative 1. So we get 4 times 7 plus 8 times negative 1 equals 20. 4 times 7 is 28. 8 times negative 1 is negative 8 equals 20. And look at that. They're equal to each other. Bottom one. Equation 2. Negative 4 times 7 plus 2 times 1. And that should all give me negative 30. Sorry, this is negative 1. 4 times negative 7. 4 times 7 is negative 28. 2 times negative 1 is negative 2. Does that equal negative 30? Negative 28 minus 2, it is indeed negative 30. And look at that. The point 7 comma negative 1 worked for both equations. So that is the point of intersection, and that satisfies equation 1 and equation 2. That's it. That was really it.